Hello, welcome to the GeoTools version 21 demo. This is Rakesh Rao and today I'm going to show you how GeoTools can be useful for your work. GeoTools is a lightweight geodata application that runs on .dwg platforms like AutoCAD and BricsCAD. In this video, you are seeing GeoTools running on version 20 of BricsCAD. GeoTools attaches itself as a pull-down menu at the end. It's also available as a ribbon, which is something new which we introduced in version 21, and it's also available as toolbars which you can open from here. All the toolbars of GeoTools can be opened and used direct. So it's really your convenience how you want to use it. It's also available on the command line. You just have to type gt underscore and you can see all the GeoTools command. So let us start with some civil tools, because civil design and surveying is the core of geography and infrastructure design. Under civil tools, we have a number of tools which are similar to Civil 3D and can be a very good replacement for that product. Okay, the first tool that I want to show you in GeoTools is from the Civil Tools section, and the tools that you find here are those which are similarly found in Civil 3D. We can confidently say that most of the Civil 3D functions are available in GeoTools. So let us start with creating a TIN surface. TIN stands for Triangulated Irregular Network. So we start with a set of points. If I just turn it around, you might be able to visualize these are a set of points of a terrain, 3D terrain. There is a boundary also next to it, which is a closed polyline. So now I'm going to create a surface out of this. So I go to Civil Tools, Surfaces, Create TIN, 3D Faces, TIN. So I choose this option called Create Surface. So when I choose this option Create Surface, what happens is an external surface is created, which means it is stored in an external file as well, so that you can move it from one computer to another or to share it with other users and so on. So I'm going to give a name to this. Let us say UAQ, that is the name of the surface. The maximum length of TIN triangle side, that is to control TIN which has got odd shapes. So more on that later, but as of now we will just click OK. This is a dialog box which tells you that you must not have any duplicate points, so that is something I've already checked. So I'm going to select this. Now it's going to build the surface and create them as TIN points within the drawing, as well as export it as a geo-DTM file. So it's done. Now if I turn it around, you can see, so this is the 3D surface of the land. Now once the surface is done, the next logical step would be to create contours. So I'm going to go and create contours from TIN surface. So I need to choose my surface that I've created now. So this is a UAQ surface. So I'm going to click on this. If I do quick statistics, it tells what are the extents of this surface. So extents means x, y, z coordinate of the lower left and x, y, z of the upper right. I am more interested in the z values only. So it is important for me to note here that the surface boundary elevation is from 728 to 744. So I'm going to use that information. The contour interval is 1. So the starting Z I'm going to set it as 728 and the ending Z I'm going to set it as 745. Contour layer name I'm going to specify it as contours. Create contours as polylines and then I'll say OK. So now it's reading the TIN and it's creating the contour. Okay, so the contours have been created. So once again, if you turn it around, now you can see that I have my ground data and I have my surface and also I have my contour. So the next step that I may need is to find a cross section. So I may want to construct a road through this terrain and I want to know what is the cross section going to look like. So before we get into that, let me just switch off the contours layer. So I'm just going to go here. So I'm going to freeze the contours layer and I'm going to use, let us say, a command called spline. Okay, so let us say this is my road, the alignment that I want to pass through this terrain. Now this is a spline, so I need to first convert it into a polyline. So I'm going to use the conversion tool here called spline to polyline, which is in CADPower actually. So we go here, line to polyline, interpolate. 4 is fine. I'm going to click on this spline. So once it is converted to a polyline, my alignment is now sitting over this terrain. So next what I need to do is I need to get the elevation from this surface. So for that I'm going to use a command called drape a 3D polyline across a set of intersecting linear objects. So the source object is this one. This is my alignment. Crossing objects, this is fine. Okay, so you can see that updating 3D polyline, 148 vertices added. So you can see that it has updated it with elevations. So if you turn it around and see, you can make out that this polyline is actually passing exactly through the surface, right? So once this is done, now I can go to Civil Tools and draw cross section profile from 3D polylines. So I select this. So I'm going to do source annotation, horizontal. If I go to quick statistics, I can again get the range for the elevation 729 to 744. So based on this, I will set my reference height as 725, which is slightly less than the minimum Z. So the reference height would be 725 and the annotation text height will be, let's say, 0.75. The rest of it I'm just going to leave it as it is. Adjust is not required. Just draw vertical profile lines. Yes, looks good. Say OK, and I'm going to create the profile here. Okay, so you can see this is the cross-sectional profile for this alignment, and this alignment is passing through the terrain where we want to build the road. Now the next step probably would be to create the finished ground. So in finished ground means the exact alignment where we want to place the new alignment. So I'm going to use a very simple method here. I'm just going to use the spline command to create spline which passes through this terrain. Okay, so you can see for any civil designer, the most important criteria in road design is to minimize cut and fill, or to have the minimum number of cuts and minimum number of fills. So this is roughly what I think will be the finished ground profile. Now let us do the cut and fill volume calculation. So we will go to Civil Tools, go to Alignment, Cut and Fill. This is my existing ground and this is my finished ground. So when I click these two, automatically you can see that it's going through the data and working out the cut and fill. So whatever you see here, so these yellow lines are all fill lines and these red lines are all cut lines. So all those are controlled here in the menu. You can control every single item very easily here. Now once this is done, if you come back here, there's something very interesting I want to show you. You can see that along with my existing ground line, there is also the finished ground line, which means I have the final alignment. So I can create the road design. I can take existing data from the ground, use GeoTools to create the surface, use GeoTools to build the contours, then draw my alignment as a spline, and then convert that spline into an alignment, draw the 3D section cross section, and then also use that data to create the finished ground. So you can see this is the finished ground and this is the existing ground. So with this you can do in GeoTools almost all the commonly required road design, alignment and cross section, surveying, contours and all those. Very simple, very lightweight, and it serves the purpose. Okay, the next thing that I want to show you in surfaces is how to calculate the volume between two surfaces, or the volume between one surface and one datum. So we will again go back to our UAQ surface. This is what we have in front of us, and I'm going to go here to Civil Tools, Surfaces, and I'm going to copy a tin surface. So I'm going to make a copy of the UAQ surface under a name called UAQ lower. So what it means is that I'm going to copy and make two surfaces which have got a name of UAQ and UAQ lower. Now UAQ lower will be in its own layer. If you see here, UAQ lower, we will set the color as yellow, and for UAQ we will set the color as green. Close this, and next what I'm going to do is I'm going to change the elevation of a surface. So I'm going to change UAQ lower. I will lower it by about 5 meters. Okay, so you can see now we have two surfaces, one below the other. The green is a UAQ surface and the yellow is a UAQ lower surface. Now why I created this? This is just to have two surfaces so that I can do a volume calculation between these two surfaces. So let us say I want to do volume calculation only in this area. You can do it for the entire surface or even for specific parts of the surface as well. So we go back to GeoTools, surfaces, cut fill volume between surfaces. So here there are two options, one surface and a datum, or two surfaces. So I'm going to choose two surfaces. The first surface is UAQ and the other surface is UAQ lower. So you can see that 5424 objects are found. That is because it is using all surface data or the default boundary, which is using the entire data. Instead, I don't want that. I'm just going to uncheck that and say that use this boundary. So once you choose that, you can see immediately the number of objects have reduced because only what is inside the boundary will be considered. You can also specify the drawing unit and the units for the volume. So I'm just going to keep them as meters and cubic meters. There's also something called custom volume measurement unit. Tipper actually means a truck. So if each truck can hold, let's say, 25 cubic meter of soil, then you can mention that here, and then it will tell you how many trucks are required for actually carrying that volume between the two surfaces. Say okay, it's processing now, and now it's going to tell you the volume difference between these two. So it's done it. Now if you look at the command window, you can see that for surface 1 the total volume was so much, for surface 2 the volume was this much, and surface 1 minus surface 2 the difference is 2340 cubic meter. So 2340 cubic meter means you need 93.6 tippers or 93.6 trucks of truckload of soil to be transported to carry this volume. The next command that I want to show you is how to bring in images and points from Google Earth to BricsCAD or AutoCAD. So under GeoTools, geographic tools, there's something called Google Earth import image. Click on that. So this is a semi-automatic procedure and it requires you to follow a certain procedure, and as per that procedure you can extract the data from Google Earth and bring it to BricsCAD. So here are the instructions. First of all, some general ones, which is north, reset view is north, U is reset tilt and all that. So start Google Earth and zoom into the area of the map which you want to capture. Press enter when you are done. So let's go to Google Earth and I'm going to bring my sidebar and I'm going to search for my place of interest. Okay, so Quain municipality, I want to search for that here. Alright, so that is my area of interest and I'm going to zoom in further a bit. Now in this command, as much precision I use in capturing the information, that is going to increase my accuracy. So I'm going to use those commands U and N. U means make the view perpendicular and N means keep the north at the top. Once that is done, I'm going to remove the sidebar. So I'm ready as per the instructions from the command. Press enter to continue, so I'm going to press enter. So the next instruction is make sure that coordinates in Google Earth is set to lat long or UTM as desired. So in this case I want to bring it as lat long, so I'm going to go to tools, options and set it as decimal degrees, which is lat long. Click OK. Come back here When you're done, press enter to continue. So press enter. Next, we need to capture the coordinates of the lower left corner of the image. Bring the cursor to the lower left corner of the image as precisely as possible. When done, press Ctrl Shift C to capture the coordinates into clipboard. So I come back here to Google Earth, bring my cursor here as much as I can, and then I'm going to say Ctrl Shift C, come back to CAD, press enter. So you can see that it has captured the lat long for the lower left point. Now it's asking you to do the same thing for the upper right as well. So again I come back to Google Earth, keep my cursor here at the top, Ctrl Shift C again, come back to CAD, press enter to continue. So now I have both the lower left and upper right captured. You can see in the status bar it is mentioning what coordinates it has captured. Now save the image using file save or save image or type Ctrl Alt S. So I come back to Google Earth, go to save image. I save it as uaq.jpg and then come back to my CAD, press enter. Now enter the Google Earth image to import. So I'm going back here and selecting that same file which I created just now, and then I'm going to say zoom extents, and so you can see that already my image from Google Earth is now imported into BricsCAD. And if you do an ID anywhere, so for example if you do ID here, you can see that the coordinate that it gives is the exact lat and long from Google Earth. So this is how you can import an image from Google Earth to CAD. Please remember that this is a static image, which means if you zoom in or zoom out, it is not going to update itself. In other words, it is not a live connection to Google Earth. It is just a one-time static import of an image from Google Earth to BricsCAD. And this is very useful for rough check, rough estimate, and for creating some presentations. Now we will see also how to get the UTM coordinates. So this is the Umalkuven municipality building and this is the pin. So let us get the UTM coordinates also for this point. That's again simple. So if we go back to geographic tools, instead of Google Earth image import, I'm going to choose Google Earth point import. The instructions are pretty much similar here. First the standard set of instructions, and then the next step is we need to capture the coordinates of the point in lat long. So how to do that? We go back to Google Earth, close this, go to tools, options. It is in lat long. See, we have to capture it first in lat long, then we have to capture the same point in UTM, then we have to bring it to BricsCAD. So say OK. Now I bring my cursor here to the pin point. So I am exactly at the pin now, and I'm going to type Control Alt Control Shift C. Then I come back to CAD, press enter. So you can see it has captured the lat long. So now we need to capture the coordinates in UTM. So once again go back to Google Earth, tools, options, UTM, apply, OK, come here, Control Shift C, come back to CAD. Okay, so you can see the zone is 40 and these are the coordinates in UTM. Insert into which coordinate? UTM, lat long, or both. So I want to insert it into the lat long, so I'll just say LL. Point number, you can give any point number you want. So if you see, it has created the point here, so I'm just going to change PD mode. So you can see now the point has been created here. So if you click on this point, it has both UTM coordinates as well as lat long coordinates and the point number. So using this technique, you can import Google Earth images as well as georeferenced points from Google Earth into BricsCAD using GeoTools. Very simple, very accurate, and it allows you to do it at a very minimal effort and cost. Now I'm going to cover some of the other features in GeoTools. Since the individual features will be covered in separate videos, this is just going to be a rundown through the different categories, so you will get an idea as to what is possible with GeoTools. So under polyline tools, again we have several subsections. As you can see, there's join, there's change 2D, 3D, vertex management, optimization, cleanup, and so on. So GeoTools Polyline category aims to offer a suite of tools which can be used for a lot of analysis and cleanup. So for example, converting from 2D to 3D and 3D. So if you click on this, you can see that there are multiple options to convert 3D polylines to 2D polylines. It's not just about setting it to 0. You can do an averaging, you can set it to first vertex, you can set it to the highest Z or the lowest Z. Or under vertex management, there are some tools which are used for optimization. Densify means you want to add more vertices than there actually are in the polyline. So you can use this. Or you can remove collinear vertices. Again, it's part of cleanup action. So some of these tools are similar to what you can find in AutoCAD map. Many of the cleanup tools like removing additional vertices, cleaning the intersections, they are all available in GeoTools very easily. Under optimization and cleanup, you can see the V tools are there, which are based on distances and deflection angle. So which means if you have a long survey data and you want to clean it up, you can clean up the data based on deflection distance, deflection angle, and so on. So this section of GeoTools is directly offering you a number of features which you will find in a mapping program like AutoCAD map. Things like identify intersection points along lines, find 3D intersections, mark junction points in a network of linear objects, identifying zero elevations, highlighting elevation differences. So these are all normal 3D inquiry functions that you require when working with 3D map data, and it's easy to do all of it in GeoTools. Assigning interpolated Z values to vertices is another very important tool. Very often you have a survey data in which some elevations are known but the rest are all zero. Now you may know 2 elevations or 3 elevations between 2 points, and then the rest can be easily done by linear interpolation, and that is possible using this command. Merge adjacent closed polylines, offset polylines inside outside, insert vertex tool, and so on. We will be producing individual videos for these tools, and you can take a look at that for more information. In this video, we are just giving you an overview so that you get a bird's eye picture of what's possible with GeoTools. Then we have the draw section where we can create embankment hatch patterns, easily create 3D polylines, and there are tools for creating parcels, lots, and so on. So parcel labeling also is a new module which we introduced in version 21. It helps you to do labeling and so on. We will cover that in a separate video. Under build, we have tools like creating right of way from pavements and ramps, creating center of lines, offsetting 3D polylines, and again different ways to offset. This is a normal offset, this is offsetting with elevation, slope, offset polylines along sections, create centroid marks inside closed polylines, multiple variable measure, and so on. Now each one of these tools have been created by user feedback, which means this is not something that we thought we should have in GeoTools, but it was a result of request from actual users who ran into problems when using normal CAD without GeoTools and found that this could be improved. This was a repetition which had to be automated. So the results of those feedback are what you see here as tools now in Geo. So drape you have already seen during this demo, which is what we use to create the alignment. Another very important aspect of GeoTools as well as in CADPower is the object data management. So we offer the full range of object data functions what AutoCAD map offers, and with this you can tag your own data to entities, and you can edit them, copy them, export to Excel, you can label them, and so on. There's annotation tool where you do different types of annotations including contour annotations, point, updating, creating the length annotation, and then there are some AutoCAD map tools which are more relevant in the AutoCAD version of GeoTools. Civil tools, we already saw a few of them. There are in fact much more things like creating map grid, creating the map sheet index, multiple cross-section tools, bearings and distances, Voronoi polygons, and so on. So there are many other categories. You can see there's geographic tools, there is geological and mining tools which are useful for the mining industry. Then there are tools for transmission lines design, there are miscellaneous tools, there are selection tools, inquiry, and so on. So GeoTools is vast. There are over 400 tools in GeoTools, and it will take you a while to actually understand and use all of them. So my request to you is, in case you don't understand something or don't know what is the right tool to use, please reach out to us. We will help you with that. One other self-help for you is this command called search GeoTools CADPower commands. So if you click on that, and let's say I want to search for all tools relating to civil, so I'm just going to type civil. So you can see under civil tools, whatever is there, you can get a list of all of them. So once you see the list here, then you can go and navigate to the tool in the menu. So it's very important for you to know how to find where the GeoTools or CADPower commands are, and the search tool is very useful. Many of our users use both GeoTools and CADPower. Some of them use only one of. So we have provided an option in this command to search either in GeoTools or CADPower or both. And we also have provided option to search in the command names or description or both. In many of our commands, you will also find a video and help button, and you can use this button to access our YouTube videos which are there on the YouTube channel. It's easy to look for our YouTube channel. Just go to youtube.com and search for BricsCAD Rakesh, or you just search for GeoTools CADPower video. That is all that I have to tell you today. You can go through the files. You can download it from the link shown at the end of this video and reach out to me for any questions you have. Thank you.